Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at solving a nonlinear system of equations. So let's go ahead and get started. Now, when we're talking about a nonlinear system of equations, it's very common for it to involve some sort of a conic, which can be, let's see here, how to make this nice and clear. It could be like a circle or a parabola or some other shape like that. And what's happened is that when you have this kind of a situation, there are three potential outcomes. Let me see. So if I'm dealing with a circle, and this is my linear line right here, you can see here in this example, I can have two potential solutions. Another thing, of course, also if I go through the U like that, I can have two potential solutions as well. Now, if I'm dealing with another way is I can have one solution, and that's where it's kind of like a tangent. So it kind of goes along the line like this. And so the same thing with the parabola like so. Or I could have no solution, and that's simply where the second equation never touches the circle equation or the parabola or whatever conic shape that I'm dealing with. So those are our choices in terms of the potential solutions. So what we're going to do here is we're going to look at the equation side of it, and then I'll show you a picture of a graph of what the potential answer might look like. So, in particular for this one, I need to mention, I also need to mention that this is for, and I guess I forgot to put this here, substitution. So don't worry about the spelling, that's not the point here. Substitution, subbing. We'll just put that, substitution. That's what we're doing here, because you can also use elimination or graphing, but we're going to use substitution in this particular example. So let's get back to the point here. So our first example is going to be as follows. Let's say I have 4x squared plus yx, let me make that nice and clear, equals 4. And then underneath that I have y equals x plus 2. So now this should be very, very easy. Wherever we have a y at, we can just plug in as x plus 2, because remember, we're using substitution. That is the tool that we're using for this particular video in this particular example. So following that thought, I would have the following as I work with my system of equations. 4x squared plus x plus 2 squared equals 4. Now, what do I do next? Well, I have to deal with this square right here. And so I just know from experience, because I don't want to show every step because that'll make it take forever, that when you square x plus 2, you get x squared plus 4x plus 4 equals 4. And then bring this down with the 4x squared like so. That's what's happening here. So when you unfactor this, I guess you could say, you get the x squared plus 4x plus 4. That's what you get, equals 4. And so now I can just combine like terms. So in this particular instance, I would combine these two. The rest stay separate. I now have 5x squared plus 4x plus 4 equals 4. And of course, now we want to make it a quadratic, so I simply subtract 4 from both sides. And let me get a new screen for you. And I end up with 5x squared plus 4x equals 0. So I'm pretty close to being done. Now what I can do now is I can factor some things out here. So I'm going to factor out the x. If I wanted to, can I do that? Yes, I can. So I end up with the x outside, 5x plus 4. Now just looking at this, I can already tell what one of my solutions is going to be. One of my solutions will be 0, because if I put a 0 here, if I put a 0 here, I will get 0 here. So I can already tell, without going through all the steps, that one of my answers is going to be x equals 0. But what about the other answer? Now, this is kind of a shortcut, but if I ignore this x out here and I just deal with the 5x plus 4 equals 0, I can get the second answer. And so you subtract 4 from both sides, you get 5x equals negative 4. You divide both sides by 5, and we get our second answer. X can also equal negative 4 over 5. And so those are our two answers. So now we need to try to verify to make sure that this is correct. We found it through substitution, but is this right? Let's check it out here. Let's see here. View, next screen. All right. let's see here. I picked it up. Okay, here is our slide, our graph of the equations, that the system of equations we just solved. And so you know that we had two answers, x equals 0 and x equal negative 4 over 5. And that's the x value, so kind of like where it crosses the x-axis, if you will. And so let me zoom in, because that might help you to see this a little bit better. I'll zoom in. And so you can see right here in the graph that it's clear that it crosses the x-axis at 0. So at 0, with a y value of 2, that's where it meets, where the lines intersect at one spot. And then if you look closely over here, you can see this is less than negative 1 right here. It's definitely less than negative 1, but it's also greater than negative 5. So I'm pretty positive that this is negative 4 over 5. Or if you were to convert it to a decimal, negative 0.8. And you can see right here, these are the two spots where the lines intersect right here. So at negative 4.5 over, about 1.25 or so, and 0.2. Those are the two places. So it looks like we got the correct answer. Now let's go back and do one more example. This one's going to be unique in its characteristics, but you'll appreciate that more in a moment. So let's see here. This is our second example, and we're going to do the following. We're going to do x squared plus 9y squared equals 9. And then we got y equals 1 over 3 x minus 3. So we do our substitution again. There's nothing unique or original so far. We got x squared plus 9. Inside that we got 1 over 3 x minus 3 squared. Oh, that should be outside. Yeah, there we go. Equals 9. All right, so to save time, this is what you do. You FOIL this right here, and you get the following. You get x squared plus 9 times the quantity of 1 over 9 x squared minus 2x plus 9, like so. That's what we get there, equals 9. All right, and so now we multiply everything by 9 inside there, so distribute this 9, and we get the following. We get x squared plus x squared minus 18x plus 81 equals 9. Combine like terms, and so now we have 2x squared minus 18x plus 81 plus equals 9. Move to the next slide if you don't mind. And so we got here at the top of this, we got 2x squared minus 18x plus 81 equals 9. And so first thing we do is we subtract 9 from both sides, and we end up with the following. 2x squared minus 18x plus 72 equals 0. And now if you try to factor this, or if you try to solve for this for x, you're not going to have any success at all. You can use AC method, you can use different factoring methods. It's not going to work. You can trust me on that. We can isolate the 2 here, put that on the outside. X squared minus 9x plus 36. It's not going to work anyway. Nothing works. I tried it. You're not going to have any success here. So this is an example of a system of equation that has no solution. It's just not going to work. There's no way to factor it anymore. Now, just to confirm that, let me show you what the graph looks like so you're able to appreciate this. So I'll zoom in for you. So here's our graph, and so here's our circle here. This is our x squared. Let's see here. This is our x squared plus 9y squared equals 9 right here. And you can see it's a nice circle. That's what we would expect. And then down here we have our second guy. This is our y equals 1 over 3x minus 3. And you can clearly see they never intersect. They never intersect. This is why we have no solution. They never cross paths at all. he's way down here on his little journey, and this guy is way up here on his journey. They never cross. And so this is why we're not able to get a solution for this particular example. So let me go ahead and zoom out. So that is our problem with that one. Sometimes that happens. They're very frustrating because you keep trying to find ways to try to solve it and you never have success and you really start to get mad. But in this particular example, there is no solution. So let me go back and kind of review what we talked about in this particular video, and then we will conclude this video. So in this video, we looked at how to solve a nonlinear system of equations. And what we mean by nonlinear is that at least one of the equations in the system is not linear. So for our example, we had one where we had a circle and the second equation was a line, some sort of a linear equation. And so the way of solving them is the same as with a regular system of equation that's linear. Is just you substitute, you eliminate, or you graph, whatever one you want to use. And in this particular set of video, we were doing substitution. And so it's just a matter of plugging in the equation for the y value. Is not that deep. We've done this before, and solving it appropriately. The first one had a solution. In fact, it had two solutions. But when we moved to the second one, it was a little bit trickier. We follow all the same steps. Again, I can't review everything about factoring and dealing with polynomials and all that. We followed all the same steps, but at the end, we were not able to find an actual solution. And again, when you looked at the graphs, you can see for the first example, they clearly intersected at 2 points, but for the second one, they never intersected, which is why we were not able to find a solution. So I hope this video was useful for you and you were able to understand what we talked about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.